So, hi everybody and welcome back. This C++ tutorial series for absolute beginners. This is video 120 and in this video we continue with pointers, but I have some mistakes and let's correct them. Because I added something or I added not something and that confused probably some of you. So, let's start. The first thing here is when this lines you should have at least this lines here we stopped, and the problem was here I added this line here later to show you that we can assign a pointer to a null pointer. The problem is here, what is the mistake here? Can you see it? What the mistake here is? A hint, a pointer behaves like a normal variable. And when we watch this one here, these two lines here, I am declaring 2 times a pointer, and that is not allowed, of course. And that was only because I have here added this pointer to show you that at start you can have a null pointer, which means the pointer is not pointing to anything, which and then you can later assign it. But when you assign it later, this one works not like so. Assigning here on the bottom, I showed you how you assign a pointer, right? You take the pointer variable name and then you assign the address which you want. Here I made it right, because here not, because here it's a redeclaration. So let's get rid of this. That was the first mistake. But I made here one more mistake. Or let's say not a mistake, I forget a very important part here, or a very basic part, which is also very important. Let's cover this one also. I hope you understand now all these lines anyhow. That's very important. Let's repeat this again. Okay, first of all, you can have a pointer with a null pointer, which means the pointer is assigned to nothing. So it has not an address, it has not a connection to an existing object, right? That's more the meaning of this. Here, also interesting, this null pointer, let me explain this one too. When we say the pointer can be assigned to nothing, we use this null pointer. This is the new version, but the old version, and which you see probably more in C++, is this null or this zero. The question is why we use now null PTR instead null and zero. The reason for that is this null and the zero are integer types, and this caused problems in C++ because they thought, are you using an integer value or what is that now? Is this pointing to a special place or not? That was a little bit confusing, and that's why they invented the new type. This null PTR is really a special pointer type made for this pointer. Because when you read this one here, this is not an integer or something. This one indicates this one is special made for this pointer, and when it says null pointer, then it means it is assigning to not a special place. This is just to make the confusion away, but we have to learn as a starter this zero and null as well, because many codes out there are using null and zero more than null PTR, because this one is new. But we will use this one, so use this one from now on. And this one we have to know because many use still this null and zero. We have to differentiate. So, all right. So this is when we assign a pointer to nowhere. So to say, actually it's with null pointer, it is a special place in memory, which is 0000. And I can show you this one here when I make here a breakpoint. Start this one here. Let me show you this what happened there. It jumps here. Right now here the pointer says this strange symbol because we are at the start, not at the end. When I go now one further, we learned this debug, I hope, to understand this code. You can see when I go now one step further, and the pointer here, this pointer variable here on the bottom, you can see it's 0, 0, 0, 0, 0, 0. And this is now clear. It is this address is special made for this pointer, but you will get the same result with 0 and null 2 perhaps. Let's make it so that you can see it if this is true or not. So let's make this one. So I go this one here, and I do here a null. So, and of course I need here, and here, oops, and here one more thing here. You see this null here has a strange color, right? Another color. This color is actually a macro color. We have not talked about macro, but let's see what the behavior is. Here the same thing. I start again, the pointer starts here. I go over it, and you see it's pointing again to 0, 0, 0, 0. So it's pointing later in the same location here. And that same goes for null 2. This is the null. Let's watch this with null here. Oops, not this one. That's not the point. Let's make here the debugger fast. And here the same thing. Right, 0, 0, 0. All right, you get this. So all the versions are right, but we are using this one, this null PTR, because this one is not an integer type. These other ones are integers, and that causes confusion. And yeah, you should read this online documentations why you should use null PTR instead of null and 0. Like I said, in many codes they still use null and 0, and we have to know this. So the first thing we covered, let's cover the second step, and that was my mistake. After you have a pointer, then, and you want to assign to a pointer a value, then you use this operator of ampersand here, and then you use the variable here, which address you want, and then you can assign it to the pointer. And here, careful, here it's just the pointer, not like I did with a new declaration, because that's the normal way. Okay, we have talked about this, and if you know this one, so what is this one here again? This one is the value of the pointer, and that's very important, because about this one we will talk in a moment one more. But then I showed you in the last video how we can use the value of a pointer. Careful, we have now a problem. We have here a value, but we don't want to use this value of a pointer. Why not? What was the problem here? Because this value of a pointer is a memory address, right? The value of a pointer, you can see it here, is a memory address. And we as a programmer are not really interested in memory addresses. We are interested in the value of the which we want to use. For example, in normal variable, I want to use this 7, right? Or in this here, in this string, my name, I want to use this name, coder. I want not use a memory address which is which the compiler is using. And then the pointer said, okay, you want not use the memory address, then I give you a way to get the value of the memory address. And this is called deferencing, and here indicating with a asterisk again, but without anything else. And this one is called deferencing, which means the pointer is now going to the memory address, and then he is going from the memory address and getting the value of this memory address, which he points. In this case, the pointer says, okay, I go to this memory address, which is my value, and then after this, I go in this memory address to the memory address value, which is stored there. And then if you do this one, you can get it, or in this case, it's not a getter, we set it, we change it to 103. We did this in the last video too. And now Here I did the same thing like here. I get again the memory address here. And I said, okay, now I point this pointer to another place. And I created another variable. For example, now I'm pointing to this place. And now if I want this pointer to get this address value here, the 7, I can get it. And how we get it? We can get it, for example, with deferencing pointer variable. Yeah, pointer variable. And here with this one, I would assign it a new value. Perhaps you don't want to assign it. Perhaps you just want to get it. What you can do is then, for example, let's create here a new variable which you want to assign this value. And you can say, for example, int get pointed address value, and then so here this one is a normal int, and this one is now saying, this int says I get the pointed address value. Let's say not pointer address value. And here this is the way you can just get it. So you can see these are both, the one is just using, this one is changing it. All right, I hope that's not too difficult. And there is one mistake I made on my diagram. And the mistake was, let me show my, let's close this one first and show my diagram. And my diagram, which I showed you, I made, I hope you know what this is. This was this strange, where I tried to explain all this kind of stuff. All this kinds, what's going on here? Yeah. All this kind of stuff here, what we made here in this diagram here. First of all, I created here this telephone address, which is this one here. And then I explained to you when we create a normal variable, it creates here fast this memory address. Then it connects the name to this memory address. It connects the value which you assigned to this memory address. And the memory address itself starts with an int, which means the memory address will have a storage length about this int. So 4 bytes at least here in this case. Can be changed, depends on architecture. So with that said, I said, okay, after that we created this one. I showed you not because in my case I started with this one. So I said, I initialized it with a direct value, which means I started here creating a pointer. Here in this case was this one here. I created a pointer and assigned at the same time, while I created it, a value to it. And value means an address. And you can see I created here this one here, this pointer. That's right, that's not wrong here. The thing what I not mentioned in my diagram was a pointer compared to a reference can have a value. So that was missing this part here. Because I just made a pointer variable here without a value, and that's not correct. We can see this here. Here is the pointer, and this address of operator, it's a value. It is address which we are not really using directly, most time not at least, but it is a value which a pointer holds, and that was my diagram which was not correct. So I need this value, and this value, this address value, which you can see here, is the same of course like this, and this pointer is still pointing there. That's okay, because this pointer we need still for deferencing. And I said, what means this deferencing here again? It means you follow this pointer to this memory address which it has here saved here. It says I go now to this memory address. Here is the memory address. And now I go from this memory address to the value. So it reads this value here. First it follows this one here, and then when it's there, it's going to this value. And this one, it means deferencing. You are, in this case, I assign a new value. If I would make this one here just like so, I would just get into this way, and just getting this value here. Here I get it. That is the normal way, and get this one here. And here, in this case, I set it, which means I start with this one here. I get to this one, and now I change this one here. All right, I hope this one you understand so far. It's not so easy for starters because that's a new concept, but I hope you get it. And what I did here is just the second place. Here I assigned a new variable. Here I created first a new variable here. Again, fast created, when we create a variable, it creates fast a new memory address as an int. This memory address is 4 bytes at least. Then connected the variable name to it, connected the value to it. So this value is saved in this memory address in this 4 bytes. And we have then our int here. And then we can call a pointer. This is this line here, this pointer variable here. It's pointing now to this one because I say now pointer variable. I want not that you're pointing anymore here. That's why I have these scribbles here. First it pointed here, and then later I said now point here to this one. I changed. And this is also a very big difference about references, because reference, we learned this one as well here on top. Reference can't change this arrow here. A pointer can change it. And what we learned also, a reference has not a value, and that's why I made now this box here with a value, because a reference has not a value. Reference has just this refer, and it is using not even an address. For example, the pointer is explicitly asking for an address, for a value as an address, this one here. The pointer, the reference on the top says just give me an L value, which means here just, for example, anything which has an address. I don't care. It must be something which has an address, and then I can reference to it. In this case, I used a variable. It has a address, and that's why this variable is a L value, and this one is asking for the name. And let's compare this one here. That was our reference, right? I hope you know what a reference is and how to use it, because now it's very important. Here you see I declare a reference, and he is asking just for a name. And this variable name, it's not possible to use like a pointer. The pointer can use the value, this memory address directly. It can send it, get it, but this reference can't use this name of this variable. It is just means he can just refer to it, and then it can access it. That's it. That's one big difference also, and that's why I have to point this out. That was my bad explanation because I forget really this one here, that a pointer has of course its own value, which is this memory address, but still it is pointing to the place where this memory address is, and then it is using this value with this deference operator. So, and one more thing I have to show, which I forget, which is very, very important, because this belongs to the basics. And what is that? What is that? What do you think? What is very basic and I forgot here to mention? And actually, let's compare. We have here creation of a declaring here a variable, right? Assigning to a start point, in this case, nothing. Okay, we covered this. Very good. Then we have here a pointer, using how we use a pointer. We can get this pointer here and say, okay, I assign you now a value, which means is a memory address. Okay, which means it's not really using it. It's more, let's say, assigning a memory address, because here we are using it, but we will not use this memory address. That's the problem. As a programmer, we are more interested in the value of this memory address. That's why we go one step further and say, now I want to use it. In this case, I want assign to this pointed memory address here a new value. And how I use it? Okay, with a asterisk, deferencing it, and then I can use it, assign it, or I can get it. For example, here I just get it and assign the value which I get it from this memory address to a new to this int. Okay, these are the two use cases. And here is just again assigning to a new place. So important is here perhaps to note, when we deal with pointer, we have two use cases, because for example, when we deal with a normal variable, we have only one use case, right? We can get this variable here, or for example, to get it like I get this, or I can change the value here. These are only two steps. In a pointer, we have the two more steps. We can change the yes, here the memory address and get the memory address, or assign a new memory address. And then after we have this one, we are asking here with this one for the value of the memory address. In this case, I change the value of the memory address, and here I get the memory address. So think about pointer has two more options. What you want? You are interested in the memory address, which means most time you are assigning it or getting it, or if you are interested in the value of the memory address. But here is one more step which I have not mentioned, which is this one here. What is this? What was it? Ah, yes. This one here. What is that? Let's say we create a new pointer. How we create a new pointer? For example, int. And let's say my second pointer here, my second pointer. And now I can assign it to a memory address at start, like all time, right? But at start I say null pointer. At start I don't know where. If I don't know where, then you make this one here to assign. It has nothing right now. But my second thing what I want to mention was this one, this line what comes now. I can take my pointer variable, okay, my pointer variable, and I can assign another pointer to it. We have not talked about this one. It's very basic, and that's why I had to add to the basics. There are much million things more which we can with pointer, but this one, oops, I have two times the same thing. Pointer variable. So now I can do this one. I can assign a pointer to another pointer, right? This is similar like you are assigning an int value. For example, I assign this int, for example, to this one here. Well, how we assign this int to this one here? Very easy, right? We say just my favorite number is equal to my telephone number. Here, my telephone number. And pointer works similar. You have already a pointer, and then you assign it to the other pointer. But the question is, okay, you assign a pointer to another pointer. What we get? What we get about this one? And let's see. Well, let's see what we get here. I make here one more thing, which is, let's make this one so that we have a little bit space there. And my second pointer. So guess, before I start this one, guess what we get here. What do you think what's happened here? So we started with a null pointer, and now I get the pointer and assign here my second pointer. What do you think what we get here? It's not too difficult. I say it not, I will start it, and if you guessed right, good. If you guessed wrong, no matter worry, we are learning it. And here, that I started. And we have something like an address. The question is, what is this address? The address is just the value of the pointer. You can see it here. Where is it? Pointer variable. This is this one here. It gets here the address of this my favorite number. So it takes the address of this favorite number here. It saves it as a value. And careful, this is pointer value. Pointer value means memory address. We have to learn this. Pointer value is memory address. And this one is a pointer value, which means a pointer to a pointer means address assigned to address. And if you want now from this pointer value, the value which programmers are interested. For example, I'm not interested in the address. I want the value of the address. Then what we do again? Again, if you are interested in the value, for example, here in my output, I'm now interested to putting out this my second pointer. I want to put out this on the screen. What I have to write here. Let's do this one here. So, because now I'm not interested in the pointer value, what I have to do, it was called this deferencing operator, right? All right, let's do this again. Deferencing operator, and now my second pointer, and now with this symbol here, I say to the pointer, I'm not interested in your pointer value, which is a memory address. I'm interested in your value, which is on your pointed value address, the pointed value, the address. Anyhow, strange to explain, but you know what I mean, right? You are interested in the value of the memory address. And when you start now, you can see we have this one here. Why we have this number here? Can you explain it? Why we have this? It's very easy to explain. I hope you can it. Because my second pointer, let's see here, we have to go back a little bit, right? So from this point, my second pointer gets first the pointed variable. The pointed variable here is this changed? Let's click on it. It's changed, yes, here. The pointed variable gets this address here. This address is here, and this address says my telephone number is assigned to this here. So my favorite number has now this value and then you get this value which was here printed out. Where is it? Have it not out printed? Now let's start it again. And that's why we have here this value. Even so, we say here, careful, let's see. It was anyway not my favorite number. I thought I would use my favorite number. Okay, but it's right. I hope it was not too confusing. And in this video, I have really talked not much new. I have more repeated a little bit it and showed you some mistakes which I made on explanations. But the last word is what I have to mention here as well, which was probably also not so right, but in my way it was right. I said pointers are very powerful, right? Right, because I think it's so. But when you read online about pointers, and all experienced programmers and many programmers say pointers, you should avoid pointers where you can avoid them. So in general, they say pointers should be used only when you have to use it or when you think you should use it, and avoid it in general if you can avoid it. And what they mean with avoid is not that you just try to not use them. They mean most time there are alternatives. There are more alternatives, they are more safe, they are better to understand, and these alternatives make it easier, more reliable, and so on. So they say pointers are, yes, most time what they complain is pointers cause so many problems, for example, memory leaks and other problems which which is very hard to find later, so bugs which is hard to find. And yeah, so the majority of programmers, what I read so far, is normally complaining about pointers. And that's why they change many things with pointers. So I already said they will find more alternatives. And we will talk about all this kind of stuff too with pointers and why they say it is bad. But first of all, we as a starter, we learn pointers, because without pointers, it's not possible to understand C++, because pointers is one of the fundamental things of C++, even if they all complain. We have to learn it. You have to understand it, definitely. If you can't understand pointers, doesn't matter how worse they say it, then we have a big problem. Because C++ in many codes, they use pointers heavily, really heavily. But what they say also is, perhaps this one as last note, instead of pointers, they prefer references. And we talked a lot of references here too, right? This one here. They say, don't use pointer, this one here. Use instead this references, which behaves like a pointer. And the reason for that is references are more safe than pointer. And one reason is, here you can see a reference is one time assigned and it stays here. You can't change this pointer pointed with arrow, for example. You can't change this reference to anything other. And we will see, because you can change a pointer, let's say from this object to another object, that can cause also problems. And this kind of stuff we will talk in future, because I said this is really powerful because I still think it's powerful. Doesn't matter what others say. Because you can really get access what you want. And the problem is power means also responsible, which means you have more thing to care about when you access what you want. And this is the thing what they complaining. It becomes really more complicated and more buggy, and in general practice they say avoid pointers if you can avoid, because yeah, it makes more problems than it helps. That's so the statement, so in general what I read online. But yeah, but I think this is just preference. So if you like pointers, I personally say I still think pointers are powerful, because you can really go where you want and then use that what you want there. All right. With that said, I stopped this video because that was just a little repetition. We have not learned many things new here, but we will still train this heavy, because there are many things we have not discussed. For example, pointers with function, pointers with real included in code, and so on. But I hope that you understand now these lines one more time, which lines you have to understand. I point this out. First of all, let's see this line here. This is the if you don't have an address, use this one. Then if you have an address, you can assign it like this line here. And with this one, you get what? You get just the address, memory address. And we as a programmer are most time not really interested in the memory address, but we need this step here to get an access to our new memory address place. That's why we need this step here. But we are interested in the value. What we do? Yes, we use this deference operator here. And deference operator we can use, of course, in two ways. One, to assign a new value, like here, or in this case here, when I see out, I just get the value here to print it out. Okay, this line is important. The next thing is here. Here is just a new, it's the same line like here. Let's kick this out here for a moment. Not very important. It's the same line like this one. We assign a new place, a new access point. All right, and which line you should know here? This one. What is that one here? This one is creating a new. No, it's not creating. What is that? What I'm doing here? This one is the use case. This is the same like here. This one is assigning a new value to the pointed memory address, and here is getting the value of the pointed memory address. You can see this one and this one is same, and this is deferencing, which means get the value of the pointed memory address. And here I assign this value to this value, and this is also very important why I can do this. You can't do this all the time, because if this value which it gets, it's not an int, you can't use this assignment operator here. So we have to learn this. We will learn this a little bit training in future. We will talk more about pointers and hopefully train this, and you should train this too. So you should understand this line here. Then here I created a new pointer. It's the same line here, so if you understand this one, you should understand this one too. And here this is the new line here, and this new line here is just a pointer assignment to a pointer, which means you can have now, yes, you assign the value. Important, and you use this one, it is the value of the pointer, not the difference value, which we won't use a programmer. This is the pointer value, which is a memory address, and we can assign it to a pointer because this one is asking a memory address. So you can see this one is one way to assign to a pointer a memory address if we have already a pointer, or we can use here this this ampersand address of an not pointer. This one is for example a variable. This one gets us the memory address from anything we want here, this ampersand memory address of this variable. This variable can then anything what you have defined before as a variable. So we have to learn these things here. If you understand this one here, these are basics, because there comes now on top of this, there will come functions and pointers to pointers to pointers, nested pointers and array pointers, strings and chars. There come so many things after this one with pointers. And of course, the big problems which all people concern with pointers, because why they is not so safe, why we should use alternatives. We will talk about this a little bit more, but as a starter, you really have to understand these lines here, and train this perhaps as well. If you do this, this is really, really good, and because starters has problems with this one here. The most thing what you should do at start, a hint, try to identify when it is a declaration, when it is a deferencing, how you can, when it's a pointer assignment to a pointer, and yeah, try to train this a little bit if you can, because yeah, just to analyze this at start, that's a very good accomplishment for starters. And later we can dive more in deeper things. So I think I stop at this and hope that you understand this. If not, no worry. Pointers are a little bit difficult, but we will manage it. So with that said, if you have any questions or any complaints like all time, write it in the comments. See you in the next. Bye.